Good afternoon. Just let me know whether I'm audible or not. Respond in chat box only. I'm audible. Yeah. Let's start. This is last part of this module. Maxima and minima of a function of two variables. Let's consider a function, say, f of x comma. This is a function of two variables, x and y. And this is y-axis. This is x-axis. Let's consider an arbitrary curve which starts from the origin like this. Goes up to infinity like this. Here, this curve goes up to infinity, we cannot find the maximum, but this is the minimum value of the function. We can find only minimum value. There is no maximum for this. Consider one more curve. It goes like this, up to minus infinity. Here we cannot find this minimum value, but we can find only maximum value. We can find only maximum value. This is maximum value and this is a minimum value. Let's consider one more example. Start from this point and ends at this point. Clearly, this is maximum and this is minimum function. Both maximum exists, minimum exists. At these points of maximum and minimum, derivatives are equal to 0. Partial derivative of f with respect to x is equal to 0. Partial derivative of y with respect to partial derivative of f with respect to y is also equal to 0. Both the partial derivatives are equal to 0. This is the condition for any function to be maximum or minimum. First, we find the stationary points such that fx is equal to 0. Fx means del f by del x. Fx means del f by del x. This is equal to 0. And del f by del y. This is also equal to 0. This is first condition for any function to be maximum or minimum. By solving these two equations, this will be an equation, this will be an equation. By solving these two, we get a set of points like this: x comma y, x1 comma y1, and so on. These points are called stationary points. There may be a maximum point, there may be a minimum point, there may be neither maximum nor minimum point. Such points are called saddle points, which is neither minimum nor maximum. And then find fxx. Fxx means del square f divided by del x square. We denote this by a. Fxy. Fxy means del square f divided by del x del y. And then we find fyy, that is del square f divided by del y square. We find these three partial derivatives. We denote this by a, this by b, and this by c. And then compute ac minus b square. Corresponding to these stationary points, we find ac minus b square. The stationary point is said to be maximum if ac minus b square is greater than 0 and a is less than 0. A means del square f divided by del x square. And a stationary point is said to be a minimum point if ac minus b square is greater than 0 and a is greater than 0. In both cases, ac minus b square is greater than 0. And a stationary point is said to be a saddle point if ac minus b square is less than 0 or equal to 0. If ac minus b square is less than or equal to 0, the point will not attain maximum or minimum. Please make a note of these three steps. working procedure. Let's solve a problem. We'll come to know what actually this method is. Three steps: finding partial derivatives. So del f is equal to 0, del y, I'm sorry, fx is equal to 0, fy is equal to 0. This is the condition for any function to be maximum or minimum. And then we find fxx, which is denoted by a, fxy, which is denoted by b, fyy, which is denoted by c. And then compute ac minus b square. If AC minus B square greater than 0 and A less than 0, the point is said to be a minimum point. If AC minus B square is greater than 0, A is greater than 0, then the point is said to be a minimum point. If AC minus B square is either less than 0 or equal to 0, then the point is said to be a saddle point, which is neither maximum nor minimum. So, find the extreme values, that means maximum and minimum values of the function. Find the extreme values of f of x comma y is equal to x cube plus y cube minus 3x minus 12y plus 20. F of x comma y is equal to x cube plus y cube minus 3x minus 12y plus 20. This is f of x comma y. First working rule. What is first working rule? First working rule is equating fx to 0 and fy to 0. Equate fx is equal to 0 and fy is equal to 0. Fx is partial derivative of f with respect to x. That means differentiate f with respect to x, treating y as constant. Derivative of x cube is 3x square. Derivative of x cube is 3x square. Derivative of y cube, partial derivative of y cube with respect to x is 0, minus derivative of 3x is 3, minus 12y is to be treated as constant, therefore its derivative is 0. Derivative of plus 20 is also 0. Fx is equal to 0. Now fy is equal to 0. Fy means partial derivative of f with respect to y, treating x as constant. Derivative of x cube is 0. Derivative of y cube is 3y square. Derivative of minus 3x is 0. Derivative of minus 12y is minus 12. And plus 20 is a constant, its derivative must be 0. 3x square minus 3 is equal to 0 implies x square is equal to 1. And 3y square minus 12 is equal to 0 implies y square is equal to 4. X square is equal to 1, therefore x is equal to plus or minus 1. Y square is equal to 4, therefore y is equal to square root of 4, which is plus or minus 2. Now write all the possible stationary points which take the form x comma y. I start with plus 1. When x is equal to 1, y is equal to 2. When x is equal to 1, y is equal to minus 2. When x is equal to minus 1, y is equal to 2. When x is equal to minus 1, y is equal to minus 2. These are the four possibilities. 1 comma 2, 1 comma minus 2, minus 1 comma 2, minus 1 comma minus 2. That's what I have written here. The stationary points are possible maximum or minimum points are 1 comma 2, 1 comma minus 2, minus 1 comma 2, minus 1 comma minus 2. What is fx? Fx is 3x square minus 3. And fy is 3y square minus 12. Right. These are the four possible stationary points. Second step. A, capital letter A. What is capital letter A? Fxx. Fxx is obtained by differentiating fx partially with respect to x. Fxx means del by del x of del square f divided by del x. Del f by del x is this function. Differentiate this with respect to x. Derivative of 3x square with respect to x is 6x. Minus 3 is a constant, its derivative will be 0. That's what I have done. A is equal to 6x. A is equal to 6x. Next b. What is this b? B is equal to fxy. Fxy can be written as del by del y of del f by del x. That means differentiate del f by del x partially with respect to y. That means treat x as constant. Therefore, differentiate this fx partially with respect to y, treating x as constant. Derivative of 3x square is 0. Minus 3 is already a constant. Its derivative must be 0. Therefore, b is equal to 0. It is a constant function. For all values of x and y, b is 0. Next, c. C is fyy. Fx is 3x square minus 3, and fy is 3y square minus 2. Fyy is required. Fyy means del by del y of del f by del y. This is equal to del by del y of del f by del y. Del f by del y is 3y square minus 12. 3y square minus 12. This is equal to partial derivative of 3y square with respect to y is 6y. And minus 12 is a constant, its derivative will be 0. Therefore, c is equal to 6y. A is equal to 6x, b is equal to 0, and c is equal to 6y. We construct a table like this. A is equal to 6x, b is equal to 0, and c is equal to 6y. And horizontally tabulate the stationary points 1, 2, 1, minus 2, minus 1, 2, and minus 1, minus 2. Now let's find the nature of these 4 points. 1, 2. Let's consider 1, 2 first. X is equal to 1 and y is equal to 2. Substitute here. X is 1, therefore 6 into 1 is 6. 6 is greater than 0. And b is already 0. For all values of x and y, b is 0. And c is equal to 6y. Here y is equal to 2. Therefore 6 into 2, 12. Next, AC minus b square. AC. A is 6. And c is 12. Therefore AC is 6 into 12 is 72. Minus b square. B square is 0 square. That is 0. Therefore, this is equal to 72. And 72 is also greater than 0. What is the nature of the point? AC minus b square greater than 0 and a is greater than 0. Such points are called minimum points. This is a minimum point. Next, let's find the nature of this point. A is equal to 6 into x. Here x is equal to 1. 6 into 1 is 6. 6 is greater than 0. And b is already 0. For all values of x and y, b is equal to 0. And c is 6y. Y is minus 2. Therefore, 6 into minus 2 is minus 12. Let's find AC minus b square. AC minus b square is, AC is 6 into minus 12 minus 72. Minus b square and b square is 0. Therefore, this is minus 72, which is less than 0. If AC minus b square is less than or equal to 0, we call the point as a saddle point. At this point, the function will not attain its maximum or minimum value. Therefore, this is called a saddle point. Next, minus 1, 2. Let's find the nature of this point, minus 1, 2. X is minus 1 and y is 2. 6x. Therefore, 6 into minus 1, minus 6. Minus 6 is less than 0. And b is 0. C is equal to 6 into y and y is 12. Therefore, 6y is 12. Now, AC minus b square. AC is minus 6 into 12 minus 72. Minus b square is 0. Therefore, this is equal to minus 72 and minus 72 is less than 0. If AC minus b square is less than 0, the point is said to be a saddle point. This is a saddle point. There will be no maximum or minimum value at this point. Next last one, -1 comma -2. Let's find the nature of this point. X is equal to -1, y is equal to -2. A is 6x, therefore 6 into -1 minus 6, B is 0, and C is 6y, y is -2. 6 into -2 is -72. And AC minus B square. A is -6 and C is -2. Their product AC is 72, minus B square is 0. And 72 is clearly greater than 0. If AC minus B square is greater than 0 and A is less than 0, the point is said to be a maximum point. Therefore, this is a maximum point. 1, 2 is minimum point, -1, -2 is maximum point, and the rest are saddle points. These two are saddle points. Now we find maximum and minimum values. F minimum is obtained by substituting this point in this function. That is x cube plus y cube minus 3x minus 12y plus 20. Minimum point is 1, 2. X is equal to 1 and y is equal to 2. 1 cube 1 plus 2 cube 8 minus 3 into 1 3 minus 12 into 2 minus 12 into 2 is minus 24 plus 20 as is. This is equal to 2. This is the minimum value attained by the function f of x comma y. Similarly, we find maximum value, f maximum. F maximum is obtained by substituting this point in this function. X is equal to -1 and y is equal to -2. -1 whole cube, -1. -2 whole cube, -8. -3 into -1, plus 3. -12 into -2, -24. Plus 24, plus 20. And this is equal to 38. These are the minimum and the maximum values of the function. So please make a note of this. If you have any doubts, you can mention in the chat box or you can message me later also. Make a note of this first. Is this clear? Respond in the chat box. No. For maximum and the minimum both AC minus B square must be greater than 0. For the extreme values, AC minus B square is greater than 0. If it is less than or equal to 0, the point is said to be a maximum, said to be a saddle point. It is neither maximum nor minimum. This must be always positive, AC minus B square. If A is greater than 0, it is a minimum point. If A is less than 0, it is a maximum point. This will decide whether it is maximum or minimum point, not this point. This point decides only it is an extreme point. It may be maximum or it may be minimum. Is this clear? Karthik, is this clear? Let's move to the next problem. Find the maximum and the minimum values of x cube plus 3xy square minus 15x square minus 15y square plus 72x. And the maximum and the minimum values of this function. Let f of x comma y is equal to x cube plus 3xy square minus 15x square minus 15y square plus 72x. For any function to be maximum or minimum, if x is equal to 0 and fy is equal to 0. Therefore, we find fx and fy and then equate them to 0. First fx, partial derivative of f with respect to x. Derivative of x cube is 3x square. Derivative of x cube is 3x. Derivative of 3xy square, here 3y square is a constant, keep it as it is, and derivative of x with respect to x is 1. 1 into 3y square is 3y square. And derivative of minus 15 into x square, minus 15 is constant, derivative of x square is 2x. Minus 15 into 2x is minus 30x. Minus 15y square, there is no x here, therefore this must be treated as constant, its derivative will be 0. And derivative of 72x with respect to x is 72. This is fx. Similarly, fy. Differentiate f partially with respect to y. Differentiate f partially with respect to y. This is a question paper problem, August 2020. August 2020. Previous problem was in the question paper, January 20 and June 2019. Fy. Differentiate f partially with respect to y. That means treat x as constant. Derivative of x cube is 0. And here 3x is constant, keep it as it is. Derivative of y square is 2y. 3x into 2y is 6xy. Minus 15x square, there is no y here, therefore this must be treated as constant. Its derivative will be 0. And derivative of minus 15y square is minus 31. 72x, this is to be treated as constant. Its derivative will be 0. Therefore, 3x square plus 3y square minus 30x plus 72, this is fx. 6xy minus 30y, this is fy. For any function to attain its maximum or minimum, fx is equal to 0 and fy is equal to 0. This is the condition. Fx is equal to 0 and fy is equal to 0. That's what I have written. 3x square plus 3y square minus 30x plus 72 is equal to 0. 6xy minus 30y is equal to 0. 6xy minus 30y is equal to 0. Here you can take 6y as common factor. As 6y comes outside, what you get within the brackets is x minus 5. This is equal to 0. The product of these three terms is equal to 0 implies at least one of the three terms is equal to 0. But you cannot equate 6 to 0. Therefore, either y is equal to 0 or x minus 5 is equal to 0. X minus 5 is equal to 0 implies x is equal to 5. Therefore, y is equal to 0 and x is equal to 5. Now we have to substitute these two resultants in this equation. X is equal to 0, I'm sorry, y is equal to 0 and x is equal to 5. When y is equal to 0, what happens here? 3x square, y is equal to 0, therefore this is 0 minus 30x plus 72 is equal to 0. Here 3 is common in all the three terms. You can divide the equation throughout by 3. Resultant will be x square minus 10x plus 24 equal to 0. Just factor this equation. This is a quadratic equation. There will be two roots. What are the roots? So type in chat box. 4 and 6, right? X is equal to 4 and 6. Next second value. When x is equal to 5. When x is equal to 5, this will be 5 square. 5 square is 25. 25 into 3 is 75. Plus 3y square. Minus 30 into 5 is 150. Plus 75 is equal to 0. Therefore, 3y square is equal to 3. Therefore, y square is equal to 1. Therefore, y is equal to plus or minus 1. Y is equal to plus or minus 1. Therefore, the possible stationary points are, write all the possibilities in the form x comma y, starting from this 4 comma 0. Next 6 comma 0. And here 5 comma 1. 5 comma minus 1. 5 comma minus 1. These 4 points are called stationary points. Make a note of this. Let's find the nature of these 4 points. Let's find the nature. What is fx here? As in the previous slide. Fx is equal to 3x square plus 3y square. 3x square plus 3y square minus 30x plus 72. Okay? This is fx. And fy is equal to 6xy minus 30. Now let's find a, b, and c. A means fxx. Fxx means del by del x of del f by del x. This is equal to del by del x of del f by del x. Del f by del x is this function. 3x square plus 3y square minus 30x plus 72. Differentiate. Differentiate partially with respect to x. Derivative of 3x square is 6x. Derivative of 3y square is 0. Derivative of minus 30x is minus 30. And derivative of 72 is 0. 72 is a constant. Its derivative must be 0. That's what I have done. 6x minus 30. 6x minus 30, that is a. Now we find b. b. What is the definition of b? B is equal to fxy. Or you can write it as fyx. In either ways, you can write that. This is del by del y of del f by del x. This is equal to del by del y of del f by del x. Del f by del x is 3x square plus 3y square minus 30x plus 7. Differentiate partially with respect to y. Derivative of 3x square is 0 because this is partial derivative with respect to y. Derivative of 3y square is 6y. Minus 30x is a constant, its derivative will be 0. plus 72 is a constant, its derivative will be 0. This is 6. Fxy is equal to 6y. Next we find C. C is equal to Fyy. Fyy means del by del y of del f by del y. This is equal to del by del y of del f by del y is 6xy minus 30y. Differentiate partially with respect to y, treating x as constant. Derivative of 6xy is 6x. 6x is constant, keep it as it is. Derivative of y is 1. Minus derivative of 30y is 30. 6x minus 30. Now let's find the nature of the saddle points. These are nature of the stationary points. This is a stationary point, this is a stationary point, this is a stationary point, this is a stationary point. First we shall find the nature of 4, 0. X is equal to 4 and y is equal to 0. A is 6x minus 30. 6 into x. X is 4. 6 into 4, 24. 24 minus 30 is minus 6. It is less than 0. And b is equal to 6y and y is equal to 0. Therefore, 6 into 0 is 0. C is 6x minus 30. 6x minus 30. Not with C. Substitute. X is equal to 4. 6 into 4, 24 minus 30 is minus 6. Now AC minus B square. AC is minus 6 into minus 6, 36. Minus B square is 0. Therefore, this is equal to 36 and 36 is greater than 0. If AC minus B square is greater than 0 and A is less than 0, the point is said to be a maximum point. It is a maximum point. Now we find the nature of 6, 0. 6, 0. This point. X is equal to 6 and y is equal to 0. 6 into 6, 36. 36 minus 30 is 6 and 6 is greater than 0. And b is equal to 6y where y is equal to 0. Therefore, 6 into 0 is 0. And c is equal to 6x. 6 into 6, 36 minus 30 is 6. Now we can find AC minus B square. AC is A is 6 and C is 6. 6 into 6 is 36 minus B square is 0. This is equal to 36 greater than 0. If AC minus B square greater than 0 and A is greater than 0, the point is said to be a minimum point. The point is a minimum point. Let's find the nature of 5, 1. X is equal to 5 and y is equal to 1. When x is equal to 5, 6 into 5, 30. 30 minus 30 is 0. A is equal to 0. B is 6y, y is equal to 1. Therefore, 6 into 1 is 6. And C is 6x minus 30. X is 6. Oh, sorry, 5. 6 into 5, 30. 30 minus 30 is 0. Now we find AC. A is 0. C is 0. AC is 0 into 0 is 0. Minus B square is 6 square, 36. Therefore, this is equal to minus 36, which is less than 0. If AC minus B square is less than 0, the point is said to be a saddle point. Similarly, 5, minus 1. A is equal to 0, B is equal to minus 6, and C is equal to 0. AC minus B square will be minus 36, and this is less than 0. If AC minus 36 is less than 0, the point is said to be a saddle point. 4, 0 is maximum point. 6, 0 is minimum point. And the other 2 points are saddle points. Now we find maximum and minimum values. F is given by x cube plus 3xy square. X cube plus 3xy square minus 15x square minus 15y square plus 72. F maximum can be obtained by substituting 4 comma 0, x is equal to 4 and y is equal to 0, and F minimum can be obtained by substituting this point, x is equal to 6 and y is equal to 0. This session will be terminated now. Join immediately. Again.